Okay, for this last example, we're looking at a problem. Researchers identified college students who generally were procrastinators or non-procrastinators. Y'all know who you are. The students were asked to report throughout the semester how many symptoms of physical illness they had experienced. Early in the semester, procrastinators, procrastinators, need to fix that right there, procrastinators, reported fewer symptoms, oh my goodness, but late in the semester as work came due they reported more symptoms than their non-procrastinating peers. I apologize. At the beginning of the semester, procrastinators reported an average of 0.8 symptoms. So this is what they started with. You can think of this as being like your y-intercept at time 0. So they had 0.8 symptoms. This is our fixed amount. Increasing at a rate of, so our rate of change is a positive 0.545. So this is our slope. It's a positive 0.54. We're increasing by a little bit less than half a symptom per week. And my pen is slurring there a little bit. Whoops. So here, so it's 0.45. You can think of as our slope. So it's our average rate of change per week. We're asked to write a function that models the average number of symptoms, y, after x weeks. So we can write this as after x weeks, y will be whatever we started with, which was our 0.8 an average of 0.8 symptoms, plus, oh, and this is driving me crazy, plus each week we gained 0.45 per week. 0.45 symptoms per week were reported. So this function models the average number of physical symptoms for procrastinators. Now, in part B, it says at the beginning of the semester, non-procrastinators reported an average of 2.6 symptoms. So they started with 2.6 symptoms, and it increased at a rate of 0.15 symptoms per week. So they started out with a lot, but it didn't increase as greatly. So the slope was a little bit, was not quite as large. Write a function that models the average number of symptoms, y, again, after x weeks. So x is our number of weeks. So we start out, so our y-intercept, you can think of it as 2.6, and our slope, our rate of change is 0.15 per week. Now, so this models our procrastinators. This is our procrastinators, and then part B is our non-procrastinators. And we are being asked by which week in the semester did both groups report the same number of symptoms of physical illness. Now, what you can do is you can set both of these equations up as a system of linear equations. So we could go in here. Alright, sorry. My computer is obviously having a hard time. Let's try that again. So you can go in here and rewrite these as a system of linear equations. So I could rewrite this as y equals to 0.8 plus 0.45x, and y equals to 2.6 plus 0.15x. And excuse my sloppy pen there. And you could actually convert these all to ax plus by equals to c and then use elimination. Or we can use substitution and just, if y is equal to this in the first equation, then we can replace y in the second equation with that value, with that expression. Or we can just simply think about, if we want to know the groups, the number that they reported. So y is the number of symptoms. We want to know when they had the same number. Really, we just want to know when the number of procrastinators, which is going to be represented by 0.8 plus 0.45x, equals to the number of non-procrastinators, which is 2.6 plus 0.15x, which is what you would do if you substituted this into here for the y. So now we can solve. I'm going to subtract my 0.8 from both sides, and I may not have enough room to do all this. I'm going to end up with 0.45x equals 2. And that's going to be what, 1.8, 2.6 minus 0.8 is, 2.6 minus 0.8 is indeed 1.8. So that's going to be 1.8 plus 0.15x, and I apologize, I'm running off here. So now I'm going to subtract 0.45 from each, 0.15 from each side, so this is going to be 0.45x minus 0.15x. And so I can subtract 0.15x here, and when I do that, that's going to give me 0.3, I believe. It's late, so I don't want to skip too many steps. And this is, I'm left with 1.8. Divide both sides by 0.3, and I get x equals to 6. And if you recall, x is the number of the average numbers, or excuse me, the x is the number of weeks. So by which week in the semester did both groups report the same number? So they reported the same number in week 6. And how many symptoms were reported by each group? Well, I'm running out of room here, but what you can do is you can go back to your original equation, and our procrastinators at week 6, we can calculate that, and our non-procrastinators. So my procrastinators would be 0.8 plus 0.45 times 6, and that gives me y is 3.5 symptoms were reported in week 6. And if I calculate here for B, hopefully we're going to get the same thing, 2.6 plus 0.15 times 6 is also 3.5. So what this tells us, by setting these equal and solving for x, we get the ordered pair 6, 3.5. And in week 6, both groups will report the same number of symptoms of physical illness, and it will be 3.5 symptoms. Now, I also want to do this with the graphing calculator again. So let's see. If I go back into my y equals, and I'm going to type in my first equation, which is 0.8x plus 0.48, 0.8, I apologize, plus 0.45x. And in the second equation, I'm going to clear that out, 2.6 plus 0.15x. And so then these numbers, 6 and 3.5, I could just look at a standard viewing window of -10 to 10, -10 to 10. So if I could go to Zoom, come down to 6 and select standard, that's going to give me a standard viewing window. And you can see my first function and then my second function. You can see that the y-intercept for the procrastinators, which is this blue line, is lower. So the starting point for the procrastinators is lower than the starting point for the non-procrastinators. But the non-procrastinator symptoms don't increase as much, as quickly, and nor the procrastinators increase a little bit more rapidly, and their point of intersection is right there. So I can click on second, calculate, and I can come down here to intersection, so 5, and it asks me, is this one of the lines? Yes. Is this the other line? Yes. And we get to guess, and then we can find that point of intersection is 6 and 3.5. So you can see you can do that with the calculator, but what's most important to me is the fact that you understand what those numbers 6 and 3.5 mean. After 6 weeks,